Okay, this example says a negative ion sports bracelet claims to increase athletic performance. To test the bracelet, 8 runners are asked to run a mile wearing the bracelet. Their times without the bracelet in minutes are compared to their times using the bracelet shown below. So here we have a bunch of runners. And so this is like the first runner. He or she ran the, whatever it is, the some kind of distance in 7.4 minutes. And this person, oh, no, it's the same person. Yeah, well, let's make sure. Yeah, there's 8 runners. Let me get this straight here. There's 8 runners, and they're asked to run a mile wearing the bracelet. Their times without the bracelet are compared to their times using the bracelet. Okay, so yeah, these two numbers are the same person. They're the first person. He or she ran it with no bracelet and did it in 7.4 minutes. Then he or she ran it with a bracelet and did it in 7.2 minutes. A little faster with the bracelet, seemed like it helped. And here's the second person. They ran the mile in 10.1 minutes without the bracelet, with no bracelet, and then 9.9 minutes, a little faster with the bracelet, seemed like it's helping them. And here's the third person. They also did a little better with the bracelet. But then, like the fourth person, notice right here, had a little higher time when they wore the bracelet. So anyway, so these are, and this is like, you know, the fifth person here, sixth, seventh, and eighth person. So there's 8 people, 8 runners, and they all ran twice. They ran the mile with the bracelet and without the bracelet, or no, sorry, with no bracelet at the top and then with the bracelet on the bottom. So the point of this is this, if we go back to the notes, let me show you the notes back here. Here's the exam 4 notes. And so what we want to figure out is this independent means or dependent, because it's data. We know there's data, right? We clearly see 2 lists of data, but there's data in 2 places on our notes here, on exam 4 notes. There's data here and there's data here. Which one is it? So it's independent or it's dependent with data. Which one? Independent or dependent? The answer is it's dependent, because data is matched in pairs, like actor, actress, male, female, before, after, with, without. Yeah, that's us. It's dependent. This is a dependent data. What do we mean dependent? Dependent means connected, meaning these 2 numbers are definitely connected, because the 7.4 and 7.2, that's the same person. That's he or she running the course with no bracelet and with a bracelet. They're connected, they're related, they're dependent. Like, you know, children are dependent upon their parents. Your relatives are your dependents. They're connected to you. So they're connected, dependent data. Now they could have done this whole study differently. They could have just had like 10 or 8 runners run the course, you know, with no bracelet, and then 8 different runners run the mile with a bracelet. You know, just 8, so 16 runners altogether. 8 running with no bracelet, 8 running with a bracelet. They could have done it that way, and that would have been independent. In that case, there would have been no connection between the numbers in the top and the bottom. They're separate, they're independent, they're not dependent. But the way they did this one, they did dependent, connected, because this is the same person. It's only 8 runners, and each runner ran twice, once with no bracelet, then once with a bracelet. So this 7.4 and 7.2 numbers are very much connected. The top and the bottom numbers are connected. They're the same person running the mile with no bracelet and with a bracelet. So they're dependent. They're connected. So that's what we have to recognize. So once we see that, we go, oh, okay. So come up here. Where are we going? So it's to dependent, which means we're going to go to the online calculator to dependent samples with data. So that's where we're going. Let's go there, to dependent samples with data. So I'm going to go to the calculator. Let me go back to the calculator menu. It's going to be way down here at number 20. And there it is, 2 dependent samples with data, number 20. We go on in there, and it opens up, and we're going to have data 1 list and data 2 list. So we got to paste our data in there. Let's go back and find that data. So I'm going to come on down. Here's the question. So I'm going to, So I'm going to copy and paste that data. So here we go. I'm going to copy it, and then I'm going to go back up to the problem, and I'm going to paste it. And you got to put commas between them. So again, this is the dependent samples with data. Stick those commas between. Okay, and then we got to go data list number 2. So now we're gonna copy that. Oh, wait. Did I just copy the wrong? I did. I went to create the wrong question. Oh, close one. Okay, here we go. So let me try this again. So I'm doing the bracelet example. I went to the wrong example for a minute. Yeah, don't do that. All right. Copy this. There we go. Copy the with bracelet. Now let's go back and paste it in there. There we go. And put in those numbers. So we'll put those in there and put commas between them. As you know, you can leave, you don't need to fix the spacing, but you do got to put commas between those numbers. All right, there we go. Now, we don't need to mess with the radio button, but we do have to put in the confidence level, the CL. Right here, the CL, we got to put that in. So let's go find out what was the CL. I don't even remember, honestly. What was it? Oh, it was right here, 85% confidence. So we're going to put in confidence level 0.85. Got to make it a decimal like we do with all fractions at all times. So back to it, 85.85. And then that's it. Hit calculate. Boom, there's our numbers. Again, this is the 2 dependent samples data calculator. So you can look at them down here in the bottom of the curve. Those 2 numbers, but they're also the lower bound and the upper bound numbers. So whatever works for you. Here, let me just grab them. Here, I'll just bring it over and paste it in here where we can see it. You can see it nicely that way. So there we go. Yeah, so looking closely at it, we can see right here, here's the lower bound, the upper bound. That's all we care about. We don't care about the T's and the P's. But they've also brought them right there and right there, kind of nicely rounded for us already. So we can just use those, you know. So it's negative 0.192, if you can see that, and regular positive 0.167. Those are our 2 lower and upper bound, the same as the numbers here, just already rounded for us, for the confidence interval. So then let's go back to the question. Is that the 2 numbers? Yeah, negative, just rounded 2 places, and 0.17 rounded to 2 places with a comma in the middle, parentheses around them. That's the 85% confidence interval. Okay. So now, what does that mean about this final question? According to your confidence interval, does the bracelet improve run times? I mean, that's the question, right? Does wearing the bracelet claims to make you run faster? Does it? Is there statistical evidence that it works or not? Well, there's 3 options here. Basically, these 3 options are inconclusive, or it improves, or it worsens. Which one is it? Well, this is where you need to look at the notes. The notes will help you. Let me jump down here to the notes. See if I've got a copy of those notes handy. Don't remember where I put it. Not that one. It was close though. Not that one. I did that one already, huh? There it is. That's the one I want. Yeah, so this one right here, this is the unit for notes. So the unit for notes right here, the meaning of a confidence. So this basically says, look, if your confidence interval is 2 negative numbers, jump to the end. That means the first group's lower than the second. If you get 2 positive numbers, jump to the end. That means, in fact, maybe just change the color to make it more clear. If they're both positive, it means the first group's higher than the second. And lastly, if you get 1 negative, 1 positive, some negative, some positive, it means there's no confidence, could be different, could be the same. It's basically inconclusive. So that tells the story. And which one's ours? Well, we're right here on part C. We have a negative and a positive, it's inconclusive. Let's come up here and we go, oh, okay. So see how we have a negative? Here, let me just write negative. We have a negative and a positive. So we are inconclusive. That's why you see the answer down here. So it's inconclusive. It's not conclusive. Now, let me give you a logical reason why, not just, hey, there's the table, pop it in. But why does that mean inconclusive. Well, think about this. If I take if I say, hey, I ran the course in 7.4 minutes with no bracelet, right? And then I ran it in 7.2 with the bracelet, ran the mile, you know, subtract those, that's 0.2, it's a positive 0.2. So if I get a positive answer, what does that mean? That means the first number was higher, doesn't it? Which means no bracelet is higher. So with bracelet is lower, that means it works. Wouldn't that mean it works in this case? Because that means the no bracelet time was higher, the with bracelet was lower, which means, hey, if it comes out positive, you subtract them. And remember, you might think, why are you subtracting them? Well, that's what we're doing. It says it right here. Where does it say it? Right here. Well, no bracelet minus with bracelet. That's a difference. Remember, this is a difference. We're taking the top group, the no bracelet, and we're subtracting the with bracelet time. That's what we're doing. So if we get a positive overall answer, that means the thing works. Now, vice versa, if we were to subtract them, what if we get, you know, 6.9 with no bracelet, the top numbers, and we get 7.3 with the bracelet, like higher, you know? If you subtract those, you're actually going to get negative, like whatever, 0.4. So it's negative. You get a negative answer. That means, now the top one, this is lower, and this one's higher, right? The 6.9 is lower, the 7.3 is higher. That means the with the bracelet time is higher. It's worse. It means it worsens. The bracelet actually worsens your run time. So if you got a negative answer, that means the second number's higher, the bracelet's higher, it takes you longer to run the mile, worsens it. If you get a positive answer, that means the first number was higher, the second number is lower, the bracelet time is lower, it works. But if you get, what did we get? Well, the truth is we got both negative and positive. What do you mean we got negative? Well, we're just not sure if the answer ends up negative or positive. We're saying we're 85% confident that the real truth of like everybody who would ever use this bracelet is somewhere between negative 0.19 and positive 0.17. So we don't know if it's negative or positive. So we're inconclusive. We're just not sure if the bracelet's working or not. The data in this table, these 8 runners, it's just not strong data, leading us to a conclusion one way or the other. That's why that is. And so there we go.